Hello, everyone, and welcome to the Javaforum's first talk. I'll discuss Polyglot JVM development. Try to say that 3 times when you're drunk. It's a good start of the evening, I promise you. But it's about how to combine different languages and when to combine them, because there is starting to get to the point where there's a business case of doing that. So, let's take a look. First of all, hello everyone. My name is Lennart Jörelid. I'm a dev and an architect, and I've worked with Java since it was called Oak, actually, but it's a few years now. I usually work with developing, server-side projects, basically, and also quite a lot in the open source world. This talk is basically divided into 4 sections. I'll try to be rather heavy on the examples, otherwise it becomes very, very theoretical and very weird. But basically, we'll take a look at why this is even a case, or rather why the case has gotten to the point where there's a business case even, not only a technical cool case, to actually combine different source code languages that all combine to or build to bytecode. And Kotlin is the golden poster child at the moment of this. There have been other attempts earlier on, but for one reason or other they have stopped at being attempts. And so I'll deal a little with Kotlin, because I guess there are some of you who haven't actually worked with it. And then we'll take a look at the polyglot stuff. When and why do you start to inject other languages, and why would you do that? And then a bit of Q&A. I'm also available after the talk, because I have got a feeling there will be a few questions, so feel free to do it both, at the end of the session and out over a cup of coffee or something. Ooh, and now PowerPoint got me the rays from the sky. Interesting. All right, and I guess it means it's because I'm going to say what this talk is not about, because it's not about Kotlin programming in general. It will take quite a long time to walk through one language, and to compare it to another language in 40 minutes is beyond me, and possibly beyond 1 or 2 of you too. So we'll just assume that you know Java, and some of you may have played around with Kotlin a bit. It's neither an in-depth usability engineering talk in 40 minutes, and it isn't anything about compiler or language design, but we'll touch base on some of these aspects here and there. It sounds very hoity-toity, but it's actually very down-to-earth. So let's start with the Java development side of things. And since it's after hours, we'll start with a bit of exercise. So try to wrestle free your right arm and be prepared to raise it or not as we go through some very basic questions. First of all, who of you have played around with Kotlin and worked with it? Okay, so quite a few of you. Who of you have actually used Kotlin professionally or in professional projects? Few of you. How many of you are Android developers? Okay, so some at least have worked with Kotlin professionally without being on an Android platform. Cool. So let's start with another question just to set this topic up. Hands up again. Who thinks it's possible, I'm probably standing where I shouldn't, is it possible to write object-oriented programs in C? Hands up. Okay. Right, so for those of you who didn't think so, there's actually quite a few books and quite a few dissertations and quite a few examples on the net where you actually write object-oriented code in C. The question is, if it is possible, because I tell you it is possible, then why don't we do that professionally? Why is there no big projects that actually write object-oriented code in C? Because to the best of my knowledge, there isn't one, really. Or there are very few. Sorry? Yeah, for a rather interesting definition of object-oriented, but yeah, true. They claim to, indeed. So why is it that C as a language isn't used? Well, there are quite a few answers for writing object-oriented programs. There are quite a few answers to this. You could go for, like, we could debate this for half an hour, but two of them would be, it's very impractical because there's no real object-oriented constructs in C, right? So if you have what we normally call an object-oriented language, then there are some keywords or some stuff in it that would facilitate, simplify creating object-oriented constructs, right? So if you do that in C, if you try to sort of emulate, if you write routines in C that would do what an object-oriented language does, it becomes cumbersome. Just to maintain the stuff that you need to do to make object-oriented software in C is very complex. Few people would be able to maintain it. And this bullet is one of the founding pillars of enterprise development. It's not okay to write clever code. And if you take a look into C object-oriented implementations, they are blindingly clever. And almost two people in the entire room would probably be able to follow it. The problem is, if you're in a group, you have to be able to read and understand code. Clear code over clever code any day. Otherwise, bugs will ensue. Right? And so, in more general terms, I promise you there's a point to this. But given the looks on your faces, it would be really funny to take a picture of you now. But okay, so reserved programming languages, or keywords in most languages, are generally just an implementation. They are fancy macros, right? There's something that a compiler would take and do something with to create a particular object-oriented code or byte code or whatever it's compiled to that solves our problem. So this is a commonly used construct, the keywords, that should be done. Those should be tailored to solve the problem at hand. It's rather important that you have a language that supports the problem you need to solve. If you don't, that's when you get these really weird libraries which are really complex to understand and do absolute magic downside because something is apparently missing from either the language or from the standard library. Right? So, if you know your history, you know that Java was actually a descendant of C. Most of the structures in Java and most of the reasons why things look as they do is because Java is called a C language. It's in the C language family. And that means basically, in order to facilitate adoption in the early days, Gosling and the company, the team that actually made Java, originated from C to make it as smoothly as possible to just migrate from Java to C, or from C to Java rather. And it was apparent that they looked at C and thought these kinds of things, pointer arithmetics for instance, generally cause problems. Let's get rid of it somehow. And much in the same way, Kotlin has had the favor of studying Java since the 1990s. It's a fairly young language. It also compiles to bytecode, as you may know, but it has had the luxury of taking a look at Java development projects for the last 20 years and finding out what are the problem points with them. What really messes Java development up, and what are the things that really could be done better? So from that point of origin, quite a lot of languages have launched. Some of you have probably worked with Scala, right? It's another take. It was a take on how should languages be done, rather than sort of what is problem with the language of the lingua franca and try to remove the kinks from it. So Kotlin is sort of a descendant to Java in the same way as Java was a sort of descendant to C, if you wish. However, Kotlin has some rather distinct design differences from Java compared to C. Because Kotlin is completely interoperable with Java. C Java is not interoperable with C, right? So when you compile something from Kotlin, you get a jar, you get bytecode, just as you do with Java. And you can easily consume stuff that is written in Java in Kotlin, and vice versa. So you don't need to rewrite what you've already capitalized on. You don't need to throw things out as you needed to do when you went from C to Java. You can just keep all the infrastructure you have and move on. That's one of the best selling points in terms of how much business risk is this. Just keep what you're used to and move on. So both Kotlin and Java compiles bytecode into jars and package them into jars, same way as Java. And Kotlin tooling is exactly the same as Java tooling. You don't need to get something new or learn something new in terms of the CD pipeline, in terms of the repository, in terms of pretty much anything, debugger monitoring, anything. All things remain the same because Kotlin just compiles the bytecode. So the same compiler as you have, well, not exactly the same compiler, but the same backend of that compiler emitting bytecode, same thing. The good thing is also that Kotlin is very much here to stay, because some of you who worked with Android from Google, Android is sort of the platform of Android really sponsors favors going over to Kotlin. There are quite a few things you can do very easily in Kotlin when you code Android applications that you really can't, well, that are quite kind of messy when you do them in Java. And that's partly because the guys that actually designed Kotlin realized that there are issues with Java in some cases. And we'll take a look at the prime issue, at least in my view, in a few slides. So not only do rather big companies such as Google and IBM and whatever work actively with Kotlin, so it's not like the odd experimentation language that will never leave the basement of someone. It's actually used actively in the industry. It's also, the tooling comes from basically JetBrains, which provide one of the, well, at least one of the good integrated development environments. There's a good chance that some of you use it on a daily basis, right? So if you know how to code Java with their tools, you know how to, well, it's the same ceremony to code Kotlin. So basically what I'm saying is, this thing is like a language progression without the pain of actually revamping your entire knowledge. You can just carry on, which is a good thing. So with the ceremony and the boilerplate of this talk at hand, let's take a look at what it is. Because why would you introduce a new language, which I recommend you seriously take a look at doing, into your big enterprise scale development, not your greenfield development, your existing development, because there's considerable gains to be done. I have tested. So the best thing, and I'll show you this shortly, is when you design your state. Think for a second of what you do when you design an entity class in Java. Something that would essentially model a table in a database or in a NoSQL store of some sort. And for one reason or other, you read that state from the database and you wrap it into an object. Consider that class. You've written that probably more than once. Right? So that state could either be domain state, like persistence, using JPA or whatever, JDBC, something that talks to a database, or it could be a transport model, things that actually convert it to XML or JSON and sends it out as a response to a request or something. So entities contain state, and they have to be able to sort of validate themselves. Right? How would you do that in Java? Well, it's the standard thing you always do. But to do that in Kotlin, we need to know how to create Kotlin classes. I'll compare that to Java, and you'll see why this is actually a rather good idea to take a look at. And you need to understand a concept in Kotlin called data classes. So that's the second bullet. you need to be able to apply some annotations. For those of you who work with JPA, how many of you actually use Java Persistence API? Hands up. Well, a few of you. So you know that when you write your state, there is the odd annotation here and there. Basically, there are more annotations than there are actually code in those classes. And you need to manage your constructors, both for framework for framework use and for regular use. So let's take a look at the code. This is without the annotations for JPA and whatnot. This is exactly how you'd model the stuff in Java, right? You got a class that is some car in this case, and it has a formidable trivial state. The only thing that is actually relevant here in the entire class, because it has these constructors and some annotations and a crap load of text with getters and setters, and quite a lot of those getters and setters probably only echo the argument into the state, right? So sometimes I always wonder, why would you always write a public getter and a public setter when the only thing you actually do is assign a private variable without doing any checks? Well, that's basically what is bloat. And most of this class, actually the absolute majority of the text in a standard Java state class is complete and utter bloat. It doesn't convey anything whatsoever. And I've been quite annoyed by this for quite a few years, because that bloat gives rise to the potential for bugs. Basically, the more text you've got, the bigger the likelihood that you introduce some bugs. Not to dive into refactoring and whatnot. Did you remember to add the getter when you added the state? Did you remember to add it to the hash code, to the toString, to the equals, to the compare, to the did you do that? Oh, you didn't implement the hash code. And we're actually stashing it into a collection. Okay. Do you know what you're actually doing now? There's lots of ceremony in Java to get this to work. Right, so if you do this, for only those two state variables and the definition of the class name and the fact that it's serializable, those are the only four really meaningful pieces of information in this entire class. It goes to roughly 120 lines of code. Multiply that by the normal enterprise legacy code base, and you get a crapload of text that actually does nothing. It's even worse than nothing. It's problematic because you have to maintain it. It costs, and it's difficult to understand. You have to plow through all this text because there might be in one of the getters somewhere something that actually has meaning. Did you document that? Okay, judging from your smiles, you didn't document that. That's the normal thing to do because this is bloat. Now, do the same thing in Kotlin. So if you just could cut away all this bloat and only preserve the information bits, that's exactly one of the key things that the engineers that designed the Kotlin language looked at. There's so much text that doesn't actually convey any meaning. Instead, in this case, these two are actually compiled to the same bytecode. Well, if you added getters, hash code, toString, and equals here, because that's generated automatically. If you want to override it, you can override it, but the defaults are generally good enough, at least in the majority of cases. So this is the Kotlin equivalent of that. This is roughly 3 lines. That's 120. The cost of maintaining 120 lines times your domain model is astronomical. So this, and of course, if you refactor something, that means you just change the name of a property in Kotlin, whereas you have to do the property, the getter, the hash code, the setter, the toString, the equal. You have to do a lot more work to maintain the same thing in Java. Right. So that's basically why. That's the reason why. It's not only less code to maintain, it's easier to read, and it is by far cheaper, both to develop, to maintain, and to understand. Imagine the onboarding here. People wading through, tons and tons of lines of text to get onboarded because you have got a new employee in your organization. Oh my God. So let's take a look at a Kotlin data class. This is a data class, right? The data is a reserved keyword. Just one of those things that the language engineers realized this is something we need to solve a set of problems that is recurring over and over and over again. And there is no such keyword in Java. There's a project Lombok, if someone has played around with it, which is, of course, something which is an add-on after the fact. This is part of the language. So there's a tremendous difference. This thing generates, well, not gets and sets actually, it generates hash code equals and toString. But this thing that is called val is not only a private state. It's not only the private string val in that sense. It's also, val means value, which is a constant. Var means variable, which is mutable. So that would generate both the property, the private property called name and being a string, and the getter, because it's a val. So it's readable, but not writable, right? Because that's what we normally do in Java anyway. Only you have to write the text and maintain the text. So val is immutable and var is a variable. The colon replaces both extends and implements. Is there really a difference? Yes, there is. You can only you can only inherit from one parent in Java, but you can actually implement many types, right? Really, really important that you make that distinction in the language. Or you can just replace it with a colon and never mind. This looks sort of like a constructor, right? It's the name of the class, just like in Java, and then you got some properties. And actually, it is a constructor, but it's also the definition of the state within the class. So it sort of serves many purposes. There are tons of other stuff in Kotlin, right? So I'll just wade you through some of them. If you really want to have a discussion about this, go to the net. There are tons of discussion about people having opinions. In my view, I don't have so much an opinion about the fashionability of the language, which seems to be a very high stress point when you read the debates on the net. I just see that there are mechanics and tools within this language that actually will solve problems that I have and would reduce cost for me that I normally have when I create solutions to maintain those problems and solve them. So this actually is a rather interesting thing. When you define a type in Kotlin, you can append a question mark, which means it's nullable. And if you don't, the type is not nullable, which means you'll get a compile time error if you're trying to assign null to it. Static code analysis applied. In the Java world, it would be exactly the same thing as string name and string nickname equals null. And you can assign null to any variable in Java, right? Because that's not something built into the language. C doesn't have it, so Java didn't have it at the outset. And it becomes really messy to add it on later on. So you can actually have exactly the same structure for declaring variables in the entity constructor / definition of the class, right? Val name, val registration plate. Oh, this is a stellar model of a car, but never mind. And then you've got a variable nickname because you can apparently change the nickname of your own car or some such. Note that that nickname is nullable. So you don't need to have one, or at least it could be null. But there's no not null. This is what you'd insert in Java, right? Because there was no such thing as a language support for nullability checks. They were all added after the fact. And whenever you see something, when you start to find your amount of annotations are growing astronomical in your code, that's a very clear sign that someone forgot to add this very common problem in the language or in the platform, and now they're doing it after the fact, since Java 1.5, right? Because annotations is really good. That implies we can add stuff which we forgot to add in the language, right? Right, so let's go to the next logical conclusion. So a data class car, we still model an entity here, but in this case, we've got something that I really have wanted for quite a few years in Java, default arguments, right? So it says here, this is a constructor, and there's actually a keyword constructor. And I also have an annotation I place on that constructor, which says JVM overloads. Please, compiler, since I have provided some default arguments, create all the overloaded constructors that I would normally have to write by hand in Java. Could you just synthesize them in bytecode for me so I'll be out of the way? Which means this actually would generate two constructors in the class, right? One which has 2 arguments and one which has 3. Same thing as you do in Java. So that JVM overloads tells the compiler, the Kotlin compiler, generate all the permutations of methods or constructors for me. And since this equals can be a default value, it's not only a constructor actually, if you think about it, it's sort of a builder as well, right? Because it has these, it's sort of the, when you have 3 constructors in Java and they call one another ultimately and enter their default values, it's sort of a builder pattern, only you have to write it out in, in ever many constructors. This is the same thing, only get rid of the other constructors, right? So you could create a car both by submitting 3 arguments and 2. And it would do, in this case, it would be a null nickname. And in this case, it would be the Swedish equivalent of SpongeBob. So I guess the suspension of that car would be somewhat interesting. Anyhow, you can do methods in Kotlin are defined by fun, as in function. So we're off the method word now, and it's back to function. Congratulations. Anyhow, this JVM overloads thing, we could ignore the other stuff. JVM static is the replacement for not really wanting to have static members. But JVM overloads here, you can see we've got a parse resource method here, which has 1, 2, 3, 4 arguments, but we've also got 3 default arguments, which means I can call it with a variable number of arguments, and the right defaults would be applied without me having to create a lot of overloaded methods. Because in most cases, we only let them call one another, chain them by adding default values. And in Java, you have to create lots of text to do it. In Kotlin, you declare a class loader, and of course, the type and the variable name are shifted around. Oops. And then thread current thread get context class loader. The same thing you do pretty much always in Java, right? So in the method declaration, you can actually set up the defaults, and you save quite a lot of text here, which is one of the aspects. And as you can see, in this case, there's a URL filter, which is an anonymous function. This is the syntax for it in Kotlin, that accepts 1 argument of type URL and produces a Boolean result. And we can actually inject a lambda, which is exactly a Java lambda, only noted in this way. So in Kotlin, there's native support for submitting functions as method arguments or constructor arguments, and also default values to functions. So this is an anonymous function that returns a Boolean. It's a pretty trivial anonymous function returning a Boolean, but still, you can do as complex as you want to. So the thing is, the problem, of course, this is written in Kotlin, but it's exactly the same thing in terms of adding JPA annotations if you want to use one of those object relational frameworks like Hibernate or Eclipse Link or Data Nucleus or what have you. So we're still at data class group type, and if we for a second disregard this horrendous amount of annotations, because JPA wasn't in the Java spec when the language was designed, so it's a rather clear indication that we're trying to solve a problem that Java wasn't really modeled for. And that certainly, since Kotlin, in this case I used the standard, Kotlin wasn't modeled for it either. However, still, there isn't anything more to this class than the declaration of the constructor. There's no setters or getters and bloat. There's just the variable definitions and then the load of JPA annotations, just as you would do normally in Java when you write JPA classes. No difference. The same annotation horrendous mass is still applied, but at least you don't get the bloat from the getters, the setters, and the other ceremony. So you still can capitalize on a drastically reduced amount of text for doing this in enterprise projects. And I bet you, after 10 minutes of taking a look at this, you could read pretty much, since you have Java awareness and Java syntax awareness, you can read this pretty fluently. And so could your colleagues. So the JPA annotations are the same as in Java, only you can apply them to the Kotlin class mechanics as well. And the odd thing is that if you do this in Java, it would be an at basic, at column, at ID, at generated value, and so on. But since that thing, let's take this for instance, it's a variable called ID of type long, which can be nullable and has a default value. There's a lot of information in one line. But it also is, since it's a var, it's a setter and a getter generated. So there's basically 3 places where you could put that annotation. And you have to tell the Kotlin compiler which one is it. The default is that you put it on the getter, because that's actually the most common place you put these in Java. But if you want to, note I've got the access type field. So if I have that, just as if I would have written this in Java, I want to tell the Kotlin compiler, please put this annotation on the field that is generated by, by this long, rather than the getter or the setter. So it's the same annotation, only with a prefix that tells the Kotlin compiler where to actually apply it in the bytecode. So I'll definitely, there is a week or two worth of discussions of what other properties this language and platform has, but there's some conclusions that are rather easy to draw. A lot less text in Kotlin than in Java. You don't really lose any expressiveness. You reduce the amount of text, but you don't reduce understandability. You don't lose usability. People can still read and understand what you've written, just as they would do in Java, just without the bloat, without the lots of text. There's still normal bytecode generated. There's no magic stuff in Kotlin. You just generate standard bytecode. So that means you can easily, from a Kotlin project, consume Spring or your own library you produced in a Java project, or some other jar. There's no impedance mismatch there. For those of you who worked with Scala, there were a booby trap here and there when you try to interact between Scala and Java, right? That's not the case with Kotlin. That's one of the prime goals of actually doing Kotlin. The guys wanted to be fully interoperable, and to the best of my knowledge, it is. I haven't found anything that, at least in the modern day Kotlin, it was like 5 years ago, then there was a problem, but now there isn't. So you don't need any extra stuff. You can just import a dependency and start working with it, calling methods or doing whatever you need to do. So Kotlin has lots of advantages compared to Java, which really convey into or translate into business. They translate into reduced cost and increased velocity. So you do have data classes. You don't need to generate or you don't need to implement the boilerplate. It can be generated for you. If you really want to override the toString in one of the classes, then by all means override the toString and do your special toString. You don't have to have hordes of nullability annotations to inform your colleagues that this thing can or can't be null. That's inherent in the language. And that also means if you call a method declaring an argument to the method is supposed to be not null, and the argument is null, you don't need to check for null the first thing you don't need to be defensive in terms of checking for null of the arguments just the first thing you do in a method anymore. That is done by the framework, by the declaration. Do you have a question mark or not? Well, if you don't, then the thing can't be null. You can be guaranteed of that. So all those null checks, if so-and-so is null, then throw null pointer exception with some message, are gone. So still lots of code that you don't need to write. There's a lot of similarity in terms of syntax, and the IDEs, the builders, and whatever are interoperable. So I've basically only shown you just a little bit of Kotlin, namely state, which is so obvious an advantage that I could recommend you, playing around with it and testing it out. It's definitely ready for prime time. But how about actually writing code in Kotlin? Is there a difference? Yes, there is a difference, quite a big difference. So big, in fact, I won't be doing any of that today, but I could easily discuss that with you over a beer or 7 outside of this talk. But basically, when you work with collections and functional programming, Kotlin is much more fluent than Java. It's much more geared towards catering for those types of programming constructs than Java is. Because, after all, we need to work quite a lot with collections. If you build back-end systems, you work with collections a lot. And that's really one of the things that needs to be clear. That's why the Java util streams were introduced in Java 8. Only, of course, there's quite a lot of boilerplate in those too. And Kotlin actually trims away that quite a lot. But if you just reduce your field of vision to entities for a second, then basically after assigning values to the constructor, you may need to run validation mechanics, just like you would do in a post-construct annotated method in Java, right? And the thing is called init in Kotlin, and there you run all your verification code. It's guaranteed always to be called after a constructor is invoked, just like a post-construct annotated method in Java. Only, of course, you can't get a guarantee that a method annotated with something is actually always run, because you have to have an execution environment that does that for you, whereas in Kotlin it's done by the compiler. Right. So I promised you early on here that I would give you a view of how to combine Java and Kotlin, not just walk through Kotlin. Okay, let's get to the stuff. I just wanted to give an overview, considering there are quite a lot of you who apparently hadn't worked too much with Kotlin yet. But okay, let's take a look at how to combine this. First of all, who of you, back one, who of you builds your projects with Maven? Hand up. All right, that's almost it. And Gradle, hand up. And Ant, anyone? Okay. I should probably stay there. If someone of you, if I say make and someone raises their hand, we'll have a ball. All right, so if you imagine the standard Gradle Maven setup when you build large-scale projects, you've got quite a lot of modules there, right? There are multi-module projects in general. So in that case, some of the recommendations and some of the setups on the net tell you that you can have source main Java and source main Kotlin, or whatever you want to stash them in your project, in the same project. Don't. Just don't. It will create more pain than it solves by far. Instead, create a new module and have that module be Kotlin only or Java only, so that you always produce your jar or war or whatever, your artifact, and it can be consumed just like any dependency. Don't mix two languages in one project. Because if you got source main Java and source main Kotlin, for instance, in the project, which one is compiled first? The compilers won't run in parallel. They will run sequentially, one after the other. Which one is run first, and hence which of the source code classes in the trees can depend on the other one? Could there possibly be any confusion about this ever in the enterprise? The answer, I tell you, is yes. We are easily confused. We are developers. We assume things, and they tend to be incorrect. That leads to bugs and shedding a lot of tears over a cup of coffee. So now, don't mix them. Just be as simple as you can when you set up your projects. Instead, try to extract the domain model from your current project and rewrite it or migrate it or part of it to Kotlin as a separate project, and then include that as a dependency, and you're scot-free. Then you'll get the advantages without any of the confusion, hopefully. It's actually, I guess, quite a few of you already have the model separate from the API, from the implementation in terms of projects. But just so everyone is sort of on the same, same page as me, then you'd have your model, say domain model in this case, of a software component foo in a project, and your API, which actually would contain the methods, the interfaces specifying how do you interact with your model, how do you order a ticket, how do you sell a car or whatever, whereas the ticket and the car would be the modeled in the model or the domain model, right? And then you can have several implementations. Now, the model can't depend on the API, but the API has to depend on the model. Otherwise, it can't return a model or generate a model. And the implementation, of course, need to depend on the API because it needs to implement stuff, but the other way around would create problems, right? Just normally. So in a version control system, we try to do it so as to have a folder, a directory called foo, which would imply that there would be all these projects in the software component, foo, and then have a foo model, or foo domain model, or foo transport model, depending on how you divide it. The foo API, foo SPI, foo implementation, which would depend upon one another very, very strictly. And you'd break the build if they don't. If someone actually makes a mistake, just break the build. It's easier to stop it there than not. Right? So if you don't have a model, then you basically produce a library. And if you do have a model, you've got some kind of domain component. Nothing strange there, just the pretty much business standard. And you could also be very kind to developers and include an example project with copy and paste code. How do you use the API? Well, take a look at the the unit test within the example project and copy and paste from there. I'll take a trivial example of how to structure this. So here we've got a service reactor with a few software components, one of which being the organization for a society here in town. And the organization component, software component, contains three projects. A domain model, which actually interacts with the database, a transport model, which is what you send out over the wire, and the application, which is the microservice. So the domain model and the transport model will then be written in Kotlin, just like this. Actually, they are written in Kotlin. And of course, I can show you this is open source. So I'll stop here, considering I've talked a bit. But I'd recommend you to carry on the conversation, because this is quite hard matter to digest in 30 minutes or so. And while I'm sure we can publish these links, there are quite a lot of places to get acquainted with Kotlin, to understand how they interact with Java or Kotlin classes, how you can consume and produce stuff in Kotlin that would be consumed and produced in Java, vice versa. So there's a rather good Kotlin companion. JetBrains has a tutorial called Cones. I have no clue how they came up with that name, but they kind of work. So ignore the name and just do the tutorials. If you're an Android developer or want to play around with your phone, then by all means, or maybe your TV, I'm not sure, then take a look at the Android development guide where you've got a Kotlin tutorial, how to set up and how to do this. And then just open LinkedIn or your phone book or any other place where you actually look for professional peers and find a company that says, we actually use this, and then go to work. That I can't help you too much with. You'd have to find the last part out yourself. But as a hint, there are a few in Gothenburg that actually works with this. Right. So I'll stop there. I have tons of source code to show you and walk through if you want to. Could there possibly be any questions? Then feel free to. Yep.